I will start with a small introduction about the way how it will be organized, this presentation. So this presentation will be shared between Professor Bloomberg and myself. And now I would like to give the floor for the first part about overall understanding of sustainable aspects specifically applied for the pilot measure in Gulbene to Professor Bloomberg.
It is working now.
Now it is working. I just want to introduce
Very
the
good.
Yes, yes, it's working. Yes.
Hello, everybody.
Hello.
This was a very interesting project, and we learned a lot. And if it is possible, the next slide, Francesco, please. Topicality. If I will speak about topicality, the first thing what I have to emphasize is that 40% of overall final energy usage is for heating and cooling demand, and it is, of course, a very important question. And our pilot project, if to discuss about then in fact, it is with very high added value. One of the main added value is that we got a lot of nice friends in municipalities. We got a lot of interest about this project, and when the project was realized, we arranged seminars, and there were Latvian District Heating Society were all very interested in those results, and the main problem was that from engineering viewpoint, we suggested that they have to change boilers from 1 megawatt to 200 kilowatts only, and it was very hard for them to believe that it will be enough, and therefore this project is some example that oversizes in boiler houses are very often, and they did that, and then they said that after that project finalized, Gulbene municipality said to us, yeah, we did not believe to you because all other engineers said that it will be too small boilers, but now it works, and in reality we save a lot of money, and therefore please next slide, Francesco, and I will tell you about this pilot project, and this is about sustainability in Beļģava district heating pilot measure in Gulbene municipality, and I will tell you some engineering details. Please, next slide. First of all, there was a wood logs boiler house for 9 buildings, and we started with that it is too far from heat load. We started with losses, heat losses, high heat losses in district heating pipes. We started with understanding about what does it mean wood log boilers and efficiency. And therefore, the starting point was that far from heat load were installed very old technical, from technical viewpoint and with very low efficiency boiler house. Next slide, please. And this, if it is far from heat load, then you see how the long were the heat pipes, and what was in fact with the heat losses, and 40% of heat losses in district heating pipes. It was starting point for this project. Next slide, please. And here you see boiler at the starting moment when we started this project, and the operators of boilers, 3 persons were employed in this boiler house, and a lot of physical work was used because wood logs were with the length of 1.5 meters. And at starting moment, heat consumers, of course, they were not satisfied with high heat supply tariff. It was 87 euros per megawatt hour, and in comparison, I could say that in Guben municipality they had a tariff around 65 euros per megawatt hour. Next slide, please. And then the aim of this pilot project were that, yes, there has to be changes in Beljava, and the question is, what is the direction for changes in district heating? And when we started project, Guben municipality, they knew that they will install new boiler in old boiler house, and then we discussed about the participation in this project, and they understood that, yeah, maybe it is possible to get such nice case, and this is challenge for them, and then maybe to continue in other boiler houses in Guben municipality, and therefore main idea was to reduce heat tariff and to get low temperature district heating system as pilot case. Next slide, please. Here you see the calculations of the district heating prolongation duration curve, and you see that calculations show that in the moment when outdoor temperature is the lowest, in that case is of course very important to understand what is the load in that case when 200 hours is outside temperature is minus 25 degrees of centigrade. And you see calculations show that approximately 200 and maybe a little bit more than 200, and the Guben municipality agreed that to install a pellet boiler with the installed capacity 200 kilowatts in that case. Next slide, please. Some pictures of and about heat distribution, and as you see that the new boiler house is in the very close to heat load, and you see that the red color, it is new boiler house, and there are buildings which will be supplied, and this heating system not only the temperature level will be 65 35 and return temperature 35. Is it possible? Yes, it is. Monitoring showed that yes, it was possible to do, and instead of previous 100 to 70 and then 80 to 60. And question was only about building, which was not insulated, and what to do in that case, and how to supply heat for this non-insulated dwelling building. Next slide, please. The heat consumers had heat substations, nice heat substations, and possibility to regulate and control temperature level. Next slide, please. This is the main picture, which shows monitoring data, and as you see, in reality, we reached 60 to 30 to 35, 45, depends from outdoor temperature. And of course, when we are showing this graph to others other district heating enterprise representatives, they are always looking on that and saying, yeah, is it possible? And therefore, this pilot project is in reality a real pilot project, and it shows that it is possible to reach such a level of temperatures and not higher than 65 degrees in district heating pipes. Next slide, please. And about benefits, it is the last slide, and it's very, those data are showing that used from 40% to 3.8%. Boiler house efficiency increased from 55% to 90.3%. And if you are looking on fuel consumption, then reduction, of course, it depends from efficiency, and much less fuel heat is used, and electricity consumption is reduced, and heat supply tariff 87.5 previous was changed to 69.07 euros per megawatt hour. Investment payback period 11 years. Maybe it is a little bit too large, but if you are looking on what is done, and in fact new everywhere new equipment, new pipes are installed, it means that it is a really sustainable project. Thank you very much. Now, Francesco, floor is yours.
Francesco, you're still muted.
Sorry. So I'm now going, thank you, Dagna, for the really nice overview about the pilot measure implemented. I'm now going to present you within the project LowTEMP how we deal with the sustainability assessment in terms of framework, methods, and tool finalized. So basically, within the LowTEMP project, the sustainability assessment with the integration of low temperature district heating system in already existing energy supply structure was applied to all the participating municipality. But the main focus was mostly on two of the sustainable pillars that define, of course, the sustainability assessment, namely the environmental and the techno-economic. This was specifically addressed to the development of both the pilot measures that were included in the project, as well as in the pilot energy strategy that were developed starting from the pilot. The first focus towards the identification of sustainability assessment framework within our project was to identify all the potential CO2 emission calculation method, taking into account different allocation methods. Further, basically, it followed the real core of the sustainability evaluation, taking into account an holistic perspective, implementing a life cycle thinking that was mostly addressed to the environmental life cycle and the life cycle cost analysis. Finally, a simulation model was developed based on a specific selected indicator in order to assess easily and with a user-friendly interface, the positive impact towards the transition to low-temperature district heating. Specifically, in my presentation, I'm going to have a summary of the 3 tools and the methodology applied to the sustainability assessment that I will recommend you to download from the LowTEMP project webpage. So why we decided to use an LCA approach? First of all, because it's is a scientific method. And secondly, because it is a consistent methodology that is able to identify and quantitatively measure and characterize different potential environmental impact within each stage of a product or system's life cycle. In this way, the LCA is capable to evaluate the overall environmental performances of a certain product or system, take into account a cradle-to-grave approach, so take into account the whole life cycle of such system. That means that we can evaluate the impact even beyond the final use stage, and take into account theoretically as well the raw material extraction for making potential technological solution implementation till the final waste management. So why LCA as a powerful methodological approach? Because it can give us then the possibility to compare scenarios and to evaluate environmental performance assessment, is able to identify trade-off and potential environmental thresholds, and of course because can give a methodology on how to ranking potential improvement solution. So what we did within our project and how we tailored the LCA methodology to the specific aspect of transition to low temperature district heating system. The main focus for the LCA conducted in LTDH system was addressed to all the segment of the district heating, starting from the heat production, including the distribution network, till the final consumer as both building and dwelling system. The first step to basically perform the LCA study that we developed for the three specific pilot measures where the three pilot energy strategy were implemented was the identification of the initial district heat infrastructural system in order to define a business as usual scenario. The second step was to identify which type of transitional pathway can be planned within the implementation of the new low temperature district heating. So the portfolio of potential alternative solution should be explored in terms of different type of primary energy sources, implementable renewable technology, and potential use of waste heat. The third step was, of course, to define the potential alternative solution and to have the final ranking according to the overall environmental performances. So what we did to tailor the previous approach to the case study. We first identify what was somehow the aim of the pilot measure implemented in the Belgrade parish. That was the full reconversion of a former third generation type of district heating to a novel low temperature district heating. The whole system was taking into account old wood log fire boiler with a not renovated distribution network, while the new system was taking into account the implementation of a fully renovated system, and as well including a remote data monitoring system that somehow was also a specific objective of the LCA perform. So based on that, three main alternatives respect the baseline scenario here identified with scenario number 4 were selected and compared. The alternative solution were specifically including the first one here identified with scenario 1, a renovated system, but not in low temperature regime, but still including a renovated distribution system and the pellet boiler of 0.2 megawatt, how previously described by Professor Bloomberg. The other two scenarios were the inclusion of operative low temperature condition, eventually including, like in the scenario number 2, solar PV panel for within the distribution network as electricity source. The selected functional unit for the system under investigation, here represented in the pictures, was the thermal energy supply to a certain heated area, take into account a certain lifetime of the district heating system. So what we get at the end of our study, the result basically could give the possibility to evaluate what could be the potential decrease in terms of ecological performances in all the investigated scenarios. Here, the ecological performances are expressed in terms of ecological point, here represented in the vertical axis as kilopoint, referred to the selected functional unit. Overall, the results for our specific case studies evaluate that, respect the business as usual scenario number 4, there is a decrease of approximately 50% of the overall environmental performances. It was also understood that the most important contribution for the overall environmental impact was mainly allocated to the energy flow during the operational phase, while it was marginal, the impact for the construction and maintenance phase. We can also have interesting results from the global warming perspective and the ecosystem quality respect the business as scenario, where it was determined an overall decrease of 62 and 54% respectively. So going and moving to the other two tools developed, I'm going to introduce here the main concept that was the ground for the definition of the life cycle cost tool. Here, as you can understand, for the development of the tool, the selection of the life cycle cost methodology was selected as a consistent methodology able to determine the life cycle cost throughout all certain product life cycle. Why we decide to select this method? Because of course it is a real straightforward quantitative tool that create an important understanding about the overall economic sustainability of a certain investment for any type of renovation project. And then, because it was interested to understand to which extent a potential environmental solution could be actually environmental sustainable. And in fact, we can also say that often non-environmental solutions are the least expensive, mostly at the beginning of the life cycle. So it was interesting to see when there was somehow some crossover point. For this reason, the specific tool that I'm now going to show, to present you, developed by Cottbus University, will be proposed. The life cycle cost analysis is, as a whole concept, consider not only the so-called life cycle cost part, but also it consists also on non-construction cost incomes and externality. Specifically for the tool was also considered the core part of the life cycle cost, specifically addressed to construction, maintenance, operation, and end of life. There is also an ISO standard that is regulating such a guideline, the 15606, but there is no real legal framework that is determining the way how a life cycle cost should be really performed and how the life cycle analysis should be made. How the tool was organized. The tool was organized in a Excel-based framework, take into account input sheets related to the description of the project, take into account which type of construction and initial investment and operating and maintenance cost should be used in the analyzed scenario, and also was taken into account the selection of potential end-of-life scenario. The other parts of the tool are involving the calculation part and the presentation of the results. As a methodology for the calculation, the net present value was used as a calculation method, as a real good tool to somehow present when there is an economic feasibility for a certain investment. So when basically the net present value is greater than zero, there is the feasibility to go for the investment implementation. So going to the last section of my presentation, here I present which are the main aspects of the sustainability simulation tool developed, for which the main impact and relevance was addressed to basically make a model where we could easily evaluate the environmental benefit of a certain low temperature district heating concept by the use of a simple and user-friendly interface. The tool was aiming to, of course, to support and strengthening the low temperature district heating concept as well in municipality and in eventually in other energy planning context. And then, of course, it was also used to provide consistent information to a wide audience of target groups. So starting from municipalities, including, of course, energy utilities, and eventually potential investor. So what about the structure of the model that was developed by Zebao? The structure of the model was based on a specific selected indicator, finally represented in a final dashboard. These indicators were taking into account mostly also economic, but not only, because as well some technological aspect and economic aspect were also included in order to create a sort of preliminary holistic vision of the overall environmental sustainability. These selected indicators were, of course, the overall CO2 emitted, excluding the heat production unit, any type of cost within the transitional project, the heat production cost, the way how heating sources were distributed, the potential losses in the network, and the final end user demand. So concluding, the simulation was taking into account also the possibility to create different scenario and make a comparative analysis. As here it is represented, several input and precondition input data can be entered in the model in terms, for example, of number of unit or heated living space of for different type of residential building, or the selection of different type of energy production storages or specific heating grids. So trying now to summarize from this presentation, the main conclusion about the sustainability assessment within the frame of LowTEMP project, it is actually important to highlight that it is a key, the quantification of the sustainability in order to have overarching optimization among the environmental impact, the economic feasibility, and the overall technical performances. We have seen, and it was also presented in previous presentation, how it is essential to, from one side, think holistically, but also think from interdisciplinarity point of view. What we have seen that, of course, the transition to low temperature district heating, as was presented, for example, for the pilot case of Belava, is essential and is a key to reduce the overall primary energy demand and emission. And we have seen that anyway, we need a really consistent quantitative tool to give a long-term perspective within the sustainability assessment and consequently in the overall energy planning of a certain municipality. And then, of course, it is a priority for the sake of strengthening the sustainability, increase the system flexibility. So integrating properly renewable energy, increase then energy also security, mitigate emission, and meantime also increasing the overall comfort of the end users. That was my last slide. So I would like to thank you for your attention, and sorry if I went a bit long with my presentation.